So we're talking about mirrors and lenses today. We're not going to go too in depth, but there will be portions of it on your test on Thursday. You literally are taking the test on Thursday, not Friday, Thursday. Um, if the room stays clean, if the chairs go back in the correct spots, you will be able to use your notes on the test. So some of you better make sure the room's clean. If you want to open note test. Um, so reflection of light rays. Um, reflection you see in a mirror depends on how the surface reflects light. To show how the light reflects, you can represent light waves, straight lines called rays. So most of the time, light does go in a straight line. Um, very rare does it go to a different direction. And if it does go in a different direction, it is because, as you see in the diagram, it hits the mirror. And as you can see, it is at, if you remember math terms, it is technically an acute angle. So that means that it is less than 90 degrees, the way that it reflected. So light is an electromagnetic wave. That's why you see the way it is moving. Light always travels in a straight line unless there's something that blocks it. So that means that the reflection or ray it reflect can change which direction light goes into. So you have regular reflection, which occurs when the light reflects off a very smooth surface and forms a clear image. Usually that is could be anything from a mirror, also sometimes water if it is calm and clear. Diffuse reactions occur when light reflects off of a rough surface and forms a blurry image or no image at all. Sometimes, depending on how light hits asphalt, you will see kind of like little waves and streaks. Also, sometimes it can hit different rocks, sometimes out of buildings that will reflect or not reflect. And it's not a clear image what you see on the other end.
We see our reflection in mirrors, in glass, and in water. But we do not see our reflection on walls, on pieces of paper, or on pieces of wood. Have you ever wondered why we can't see our reflection in these objects? Don't these materials also reflect light? Yes, they do reflect light. However, the reflection of light depends on the surface onto which the light falls. There are two different types of reflection of light: regular reflection and irregular or diffused reflection. Depending on the type of reflection, we are able or unable to see our reflection in certain objects. Let's have a closer look at the two types of reflections. A parallel beam of light is made up of light rays that are parallel to each other. When a parallel beam of light falls onto a smooth surface, all rays are reflected at the same angle and remain parallel after reflection. This type of reflection is called a regular reflection. Regular reflection takes place when light falls onto a smooth, shiny, or polished surface. For instance, regular reflection can occur in a mirror. Since reflected rays travel in specific directions, we can see images with our eyes. On the other hand, the surface of a paper or wall is not smooth. If we look closely at the surface of a wall, we can see the roughness of the surface. Sometimes, the roughness is not visible, and we need a microscope to see it. When a parallel beam of light falls onto such a rough or irregular surface, the reflected rays do not remain parallel after leaving the surface. This type of reflection is called an irregular or diffuse reflection of light. Here comes a question. Does irregular reflection follow the law of reflection of light? Is the angle of incidence equal to the angle of reflection when light falls onto a rough surface? When light falls onto a rough surface, it obeys the law of reflection. The normal of each point of incidence is different because the surface is irregular. For example, look at the red ray and the blue ray. Because the surface is uneven, their normals point in different directions. The angle of reflection equals the angle of incidence in each ray. That's why the red ray and the blue ray reflect in different directions. The overall effect is that the parallel incident beam reflects in all directions. A wall cannot reflect our image because the reflected rays travel in many directions. Both regular and diffuse reflection play important roles in our lives. We are able to see opaque objects due to the reflection of light. We see our reflection in mirrors and various other surfaces due to the regular reflection of light. Usually, sunlight does not reach our rooms directly, but we still can see objects around. This is caused by the diffuse reflection of light. Sunlight falls onto different surfaces and reaches our rooms from different angles. Because of diffuse reflection, we are able to see things that are not in the direct path of light. Time to summarize. When a parallel beam of light falls onto a smooth surface, the reflected rays are parallel. This is called the regular reflection of light. We see our reflections in mirrors due to regular reflection. When parallel rays of light fall onto rough surfaces, the reflected rays are not parallel. This is called irregular or diffuse reflection. Diffuse reflection allows light to travel in multiple directions, which allows us to see things that are not in the direct path of light.
A plane mirror. And make sure when you are doing notes, remember I told you, use the title and just summarize the paragraphs. Don't write the whole thing. But do you look into a mirror in the morning to comb your hair or brush your teeth? If you did, you probably used a mirror, a plain mirror that is a flat sheet of glass that is smooth and silver color coating on one side. Often the coating is on the back of the mirror to protect it from damage. When light strikes the mirror, the coating reflects the light. Because the coating is smooth, regular reflection occurs, and a clear image is formed. And the image is a copy of an object formed reflected or reflected rays of light. So, and I just learned something new. So, in the back of the mirrors, and as you in any mirror, there's always, usually it's always gray. And so, when you are looking yourself, the ray of light that is coming from your light in your bathroom is reflecting to the mirror, and you are seeing yourself. Without that gray in the back, you would probably not really see yourself like you should. Um, so that's why a mirror is a smooth and highly polished surface that reflects the light in order to form an image. Plain and simple. That's all you should write down. Concave mirrors. In concave, a mirror with a surface that curves inward like the inside of a bow is a concave mirror. Um, concave mirrors can reflect parallel rays of light so that it might at one point reach. Notice that the rays of the light shown parallel to the opti optical axis. That was a tongue tie. The optical axis is a imaginary line that divides a mirror in half, much like the equator. And if you don't know where the equator is, it is in the middle of the world and it goes all the way around. It's usually the hottest point. It's in the Gulf of Mexico, in that region. So most of those islands that are in the Gulf of Mexico are either on or around the equator, same way with Mexico and parts of Africa. Um, so the equator that divides the Earth into northern and southern halves. So the axis splits the mirror in half. So the point at which the rays parallel to the axis meet is called the focal point. And the location of the focal point depends on the shape of the mirror. The more curved the mirror is, the closer the focus is to the mirror. And we were talking about nearsighted and farsighted in our notes on Monday. So this would go into a lot deeper of why and this is why we talked about the eye also on Monday, because your eye, that lens, can also be a concave or complex vex mirror in your eye, and it can reflect the light and you can see different things. So don't write all this. I hope you're not. Definitely not. So the type of mirror that is bent towards the inward sides in the middle. That should be the most important thing you write down. And it's part of the first sentence. Um, convex mirrors, and as you see in the picture, I try to at least find something that goes with it. So the convex mirror is curves outward. So you see these mirrors usually in stores. And when you see these in stores, it shows a lot of the surface area. And that's why you see the woman shopping. And if it was a clear vision of the mirror, you could probably see some of the pictures on the products on the shelf. Um, so the rays spread out, but appear to come to a focal point behind the mirror. The focal point of a convex mirror is the point from which the rays appear to come because the rays never meet. Images formed by convex mirrors are always virtual and smaller than the object. So convex mirrors make stuff smaller, concave makes stuff bigger, or sometimes it's original size. Um, perhaps you've seen the warning on a car mirror, objects in the mirror are closer than they appear. So if you are sitting in the passenger seat of your parents' car, not in the driver's seat, but in the passenger, when they are backing up, you can see in their mirror what is clearly behind you. But it looks like it is closer than what it actually is. You can actually have sometime 1 to 2 feet in between whatever that object is because it looks more closer. That's what a convex mirror does. And they also use them in stores. Refraction of light is the bending of the light. It also happens with sound, which we'll talk about sound in months from now, and water and other waves. As it appears, as you can see how the light is shining from the ray, the ray hits the pencil. And as you look at the pencil, anytime you put stuff in water and the light reflects, it looks like it's kind of bent, but when you pull the pencil out, it's straight because it is the way that the the rays are coming from the light and the light is reflected back from your eyes. It can also cause you to see something that may not actually be there. As you look at a fish tank, the light coming from the fish to your eye bends as it passes through 3 different medians. The medians are the water, the glass, and the air. So as the light passes from one medium to the next, it will kind of mess with your eyes, thinking you're seeing something that is actually not realistic. When the light rays enter the medium at an angle, the change in the speed causes the rays to bend or change directions. So we're not going to go too into different means. But I can tell you that prisms are one. So when a light shines through a prism, it will come out at a different angle depending on what it reflects off of. And a lot of times, especially a white piece of paper, it'll show a rainbow. And that's also the way that when it rains, it does the same thing. That's why you see a rainbow. But that is more for your high school physics class. Middle school, we're just not doing it, not today. but it's a good thing to know when you see something. You never know, you might play in Jeopardy, and this might be one of your answers. Just saying. Um, lenses. This is what I was talking about, the eye, the concave lenses and the convex, the way that they different, how they look so different. Um, we're also not going to go too into detail in the lenses. It's a good thing to know, especially when you take physics again in high school. Um, and it could end up on your test in the spring, who knows? But convex lenses is a lens that coverage rays of light that they're kind of parallel, as you can see when they go in, and then because of the shape of the lens, they start to move to a focal point to the center. Um, so they, which is really, it makes it a lot thinner, and it's curved. The edges of usually stuff are outward rather than inward. Um, So as the light is parallel to the axis, passes through the convex lens, they are bent towards the center of the lens. The rays meet at a focal point of the lens and continues to travel beyond. And the more curved the lens, the more it reflects light. So when you look at, let's say, a ladybug, and you put a magnifying glass super close to it, it makes it bigger. But when you pull it back, it makes it smaller. It can change the dynamic of what you see in an object. Concave is thinner in the center than at the edges, and when the light rays travel parallel to the axis, passes through a concave lens, they bend away from the axis and they never meet. As you can tell, all the rays are coming in different directions at a parallel angle, but they never meet at the focal point like convex. So they don't come together at all. Concave lenses can produce only virtual images because parallel light rays passes through the lens and they never meet. So pretty much they bend from the axis and they never meet. So if you're nearsighted, it is more convex, and that is why you can see stuff close to you and not far away. When you're farsighted, it's concave, and that's why you can see stuff far away instead of close to you. And this is the different ways that, like the convex, that's way the lights shine through, and you can see all the beams of light are still running parallel until it reaches the focal point. The convex, as you can see, they go in parallel and then they expand and they don't reach one focal point.
Have you ever wondered why objects that are far away appear close to us when viewed through binoculars? What are the two transparent materials in front of the binoculars that make those objects appear near? And what is the object that we use to see tiny things or to read small text? Or why do we wear spectacles? What's used in the spectacles? To answer these questions, we need to know about lenses. There are two lenses in binoculars that make objects appear near. The magnifying glass, which is used to see tiny things, also has a lens in it. The lenses in spectacles help us see clearly if we have bad eyesight. So, what is a lens? In simple words, we can say that a lens is a transparent material that bends light in some pattern. These are some common lenses, and this is what they look like. The two specific lenses that we are going to cover in this video are biconvex and biconcave lenses. Each one consists of two spherical surfaces. Hence, the word bi is used as it means two. In a biconvex lens, the two spherical surfaces are curved inwards. In a biconcave lens, they are curved outwards. There's another way to look at the difference between these two lenses. A convex lens is thicker at the center and thinner at the edges, while a concave lens is thicker at the edges and thinner at the center. But how does a lens function? The main purpose of the lens is to refract light in some pattern. Remember that refraction is the change in direction of a light ray as it travels from one medium into another medium. For instance, when light travels from air into water. There are two patterns, convergence and divergence. Before discussing these patterns, we first need to understand how light is refracted by a lens. Consider a convex lens. Somewhere far off, a point object emits a ray of light that falls on the lens. If a light ray that is parallel to the principal axis falls on the lens, the light ray will refract towards the normal as it enters the lens, because the lens is denser than the air around it. This is because the lens is made of glass, which is denser than air, and this is how the light ray is refracted by a convex lens. Here, we are only showing one ray. In reality, the object will emit many rays of light. All these rays will be refracted in the same way after striking the lens. Did you see something strange? Yes, all the rays meet at a common point. We can also say that all the rays are focused or converged at a single point. This is one of the patterns that we were talking about. The convex lens bends the light rays from a point object in such a way that after refraction, all these rays converge at a single point. We also call it a converging lens. What about a concave lens? How does it refract rays? Let's have a look. Both convex and concave lenses refract light. However, the light rays are refracted in different directions. Will the rays converge after refracting from a concave lens? If the rays from a point object are incident on a concave lens, then after refraction, they do not converge at a single point. These refracted rays diverge, which means they go away from each other. Hence, it's called a diverging lens. Let's summarize what we have learned in this video. A lens is a transparent material that refracts light in some pattern. A convex lens converges all the light rays from a point object. And a concave lens diverges all the light rays from a point object.
So, this is the end of your notes. Um, make sure you keep up with them. Make sure you find the notes from Monday for your test on Thursday, which is technically tomorrow. You should be fine. It's open note. I'm not gonna put nothing crazy on it. So yeah, go home, make sure you study. If you have any workout, which we have not done a whole lot of in this unit, you need to turn it in. Fall break, I should be done grading everything. If not, hopefully before then. But I know that is what I'm going to be doing Sunday, Monday, and Tuesday and Wednesday. Those nights. When you come back on the 9th, for the next 4 weeks, we will be talking about sales. So, based on your behavior, we'll decide what labs and what we will do. My goal is to hopefully do where you create a sale and you do it based on candy. Some people have used vegetables, some use fruit, some use a mixture of both. That is the goal for your project. But if we are not putting the desks where they're supposed to, leaving the tables alone, not putting the chairs where they're supposed to be. Also, if you're in sixth period, you better make sure that every piece of trash is off the floor and your chairs are stacked on the tables. There should be 2 chairs per table. Also, my goal is to pull out the microscopes and look at the different cells, especially animal cells, human cells, looking at prokaryotic, eukaryotic cells, all those different things. But it's going to be depending on your behavior. So me and Mr. Ward will decide what you'll be doing. So have a good fall break if I don't see you in the next couple days. And turn in your work.